Equilibrium, commonly known as the sense of balance, is an essential function that enables living beings to interact with their environment in a stable and coordinated manner. This ability is not just crucial for humans but for all animals, ensuring that they can move, stand, and perform various activities without falling. The complexity of maintaining balance and spatial orientation involves the collaboration of multiple sensory systems, each contributing its part to the overall perception of equilibrium. This article delves deeply into the science of balance, focusing on the intricate workings of the vestibular system, the critical role of the cerebellum, and the lesser-known contributions of the thalamus. Equilibrioception, the sense of balance, is one of the lesser-discussed sensory systems, yet it is crucial for everyday life. This sense allows organisms to perceive their position in space, helping them to maintain stability whether they are still or in motion. The ability to remain balanced is often taken for granted, yet it is a complex function requiring the seamless operation of several sensory systems. In humans and other animals, equilibrioception plays a vital role in preventing falls and ensuring that movements are smooth and coordinated. This is especially important for bipedal organisms like humans, where maintaining balance is more challenging due to the upright posture. The sense of balance is primarily maintained by three key systems: the visual system, the vestibular system, and proprioception. Visual system. The eyes provide critical information about the body's position relative to its surroundings. When we stand, walk, or move in any way, the visual system constantly monitors our environment and sends signals to the brain about the position of objects around us. This helps in maintaining spatial orientation and balance, especially in unfamiliar or complex environments. Vestibular system. Located in the inner ear, the vestibular system detects head movements and contributes to maintaining balance. It senses changes in head position and sends signals to the brain, which in turn adjusts the body's posture and movements to maintain stability. Proprioception. This is the body's internal sense of its position in space. Proprioceptors are located in the muscles, tendons, and joints, and they provide the brain with information about the position and movement of different body parts. This sense is crucial for coordinated movement and maintaining balance. The integration of these systems is necessary for maintaining equilibrioception. If any of these systems are impaired, it can lead to balance disorders, making it difficult for an individual to stand, walk, or perform other activities without losing balance. The ability to maintain balance and spatial orientation is not the result of a single system, but rather the outcome of the integration of multiple sensory inputs. The brain acts as a central processing unit, receiving and synthesizing information from the visual, vestibular, and proprioceptive systems. The process of integration is complex and involves several neural pathways and feedback loops that ensure the body remains upright and balanced. When the body is in motion, the visual system continuously provides the brain with information about the environment. For example, when you walk down a flight of stairs, your eyes gauge the height of each step, allowing you to adjust your foot placement accordingly. Simultaneously, the vestibular system detects the angle and speed of your head movement, while proprioceptors in your legs and feet inform the brain about the position of your limbs. The brain processes this information almost instantaneously, allowing you to move smoothly and avoid tripping or falling. The role of feedback loops. One of the key mechanisms in maintaining balance is the use of feedback loops. These loops involve the continuous exchange of information between the brain and the sensory systems. For instance, if you start to lose balance while standing on one leg, proprioceptors in the muscles and joints immediately send signals to the brain about the change in body position. The brain then processes this information and sends signals to the muscles to adjust posture, helping to regain balance. Compensatory mechanisms. When one sensory system is compromised, the brain can compensate by relying more heavily on the other systems. For example, if someone has impaired vision, their brain may depend more on the vestibular system and proprioception to maintain balance. This compensatory mechanism is evident in individuals who are blind. They often develop an enhanced sense of proprioception and vestibular function to navigate their environment. As individuals age, the efficiency of the sensory systems involved in balance tends to decline. This is a significant factor contributing to the increased risk of falls in older adults. Age-related changes in vision, such as cataracts and macular degeneration, can impair the visual system's ability to provide accurate information about the environment. Similarly, the vestibular system may become less sensitive, leading to difficulties in detecting head movements and maintaining balance. Proprioception also deteriorates with age, as the sensitivity of proprioceptors decreases. This can result in slower reflexes and a reduced ability to sense body position, making it more challenging to adjust posture quickly in response to changes in the environment. To mitigate these effects, older adults are often encouraged to engage in balance training exercises. These exercises can help improve the integration of sensory inputs and strengthen the muscles involved in maintaining balance, thereby reducing the risk of falls. The vestibular system is one of the most critical components in maintaining balance and spatial orientation. It is a complex sensory system located in the inner ear, and it plays a vital role in detecting head movements and providing the brain with information necessary for coordinating balance and movement. The vestibular system works in conjunction with the visual and proprioceptive systems to ensure that the body remains upright and stable during various activities, from walking to more complex movements such as dancing or gymnastics. The vestibular system consists of several key components that work together to detect different types of movement. Semicircular canals. These are three fluid-filled tubes arranged in roughly perpendicular planes, corresponding to the three dimensions of space. Each canal detects rotational movements of the head in one of the three planes: horizontal, vertical, and diagonal. When the head rotates, the fluid inside the semicircular canals moves, triggering hair cells within the canals to send signals to the brain about the direction and speed of the rotation. Otolith organs. The otoliths, which include the utricle and saccule, responsible for detecting linear accelerations and head tilts. These organs contain small calcium carbonate crystals called otoconia, which rest on a gel-like layer. When the head tilts or accelerates, the otoconia shift, causing the underlying hair cells to send signals to the brain about the change in position or movement. Vestibular nerve. The signals generated by the hair cells in the semicircular canals and otolith organs are transmitted to the brain via the vestibular nerve. This nerve is a critical communication pathway, ensuring that the brain receives real-time information about head movements and changes in body position. The vestibular system is essential for maintaining equilibrium and coordinating movements with balance. It provides the brain with the necessary information to make rapid adjustments in posture and movement in response to changes in head position. For example, when you turn your head to look at an object, the semicircular canals detect the rotation and send signals to the brain. The brain then processes this information and sends signals to the muscles of the neck and eyes, ensuring that your head and gaze remain stable and focused on the object. Similarly, when you accelerate forward or tilt your head, the otolith organs detect the movement and send signals to the brain. The brain then adjusts your posture and balance accordingly, allowing you to maintain stability during the movement. Disruptions in the vestibular system can lead to various balance disorders, affecting an individual's ability to maintain equilibrium. Common vestibular disorders include vertigo, a sensation of spinning or dizziness that occurs when the vestibular system sends incorrect signals to the brain about head movements. Vertigo can be caused by inner ear infections, head injuries, or conditions such as benign paroxysmal positional vertigo, BPPV. Meniere's disease, a disorder of the inner ear that can cause episodes of vertigo, hearing loss, tinnitus, and a feeling of fullness in the ear. Meniere's disease is thought to result from abnormal fluid buildup in the inner ear, affecting both the vestibular and auditory systems. Vestibular neuritis, an inflammation of the vestibular nerve, usually caused by a viral infection. Vestibular neuritis can lead to severe vertigo, imbalance, and difficulty with walking or standing. Labyrinthitis, an inflammation of the labyrinth, the complex structure in the inner ear that includes the cochlea and vestibular system. Labyrinthitis can cause vertigo, hearing loss, and imbalance. Treatment for vestibular disorders varies depending on the underlying cause but may include medications, physical therapy, vestibular rehabilitation, or, in some cases, surgery. The vestibular system is present in all vertebrates, but its structure and function can vary significantly between species. For instance, in birds, the vestibular system is highly adapted to support flight, with specialized structures that allow for rapid and precise adjustments in head and body position during flight. In fish, the vestibular system is adapted to detect changes in water pressure and currents, which are critical for maintaining balance and orientation in aquatic environments. Research into the vestibular systems of different species provides valuable insights into the evolutionary adaptations that have allowed animals to thrive in diverse environments. Understanding balance and the vestibular system has a long history that dates back to ancient civilizations. Early thinkers like Hippocrates and Galen recognized the importance of the inner ear and its role in maintaining balance, even though the anatomical and physiological understanding of these systems was rudimentary at the time.